But then without further ado, I will go ahead and get this kicked off. My name is Calvin Hendryx-Parker. I am co-founder and CTO of 6 Feet Up. We are an Amazon Web Services partner, and we do a lot of consulting around Python and cloud. We've been in business now for 21 years, which sounds really weird when I say that coming out of my mouth out loud, but it is true and has happened, and we are still here to tell the story, which is something I like doing, is telling stories. So we're going to, I'm going to do a quick introduction again to Greengrass. I've got a couple demos, and I actually have, hold up over here. Hopefully I don't use too much static electricity and shock myself with this thing. So I have a Raspberry Pi here that we'll be using during the demos to show off some of the functionality. So there's no man behind the curtain. It's actually legitimately doing some actual IoT during the talk. So that should be really cool. And so let's get started. So what is Greengrass? Oops, not on the right window here. So what is Greengrass? So Amazon Greengrass is a fully managed edge service, basically part of their IoT Core product line. It enables quite a few different things, basically frees you up from having to manage or deal with a lot of the management of a fleet of IoT devices. It provides that secure communications layer, so all the data going back and forth between your what is your devices, your things, your cores, which we'll talk about what all that various terminology means here in a minute. Secures all that communication, so you can kind of rely on that layer being handled by Amazon. It allows for group management of cores. So the cores themselves are the edge devices. Well, a device running the core software at edge someplace. So you can then manage those in groups and re-provision, deploy software to them. And then over the air provisioning and updates. So keeping the cores up to date actually is done over the air and automatically by Amazon. So if you have 10,000 of these devices out in the field, you're not having to go log into all 10,000 of them or set up your own orchestrations to even go through the whole upgrade hassle and process. I mean, obviously that's optional, but it's something that's probably very desirable since it could be pretty time intensive and you don't have to manage that part of the process. What's kind of the main big features in my mind for using Greengrass is going to be the Lambda at Edge services. So you could, if you all are familiar with Amazon's serverless product called Lambda, basically you write cloud functions, you get to execute them in the cloud without having to manage any kind of servers. They're very simple and easy to write. You can do them in Python and Node and Java. Well, the Greengrass service actually allows you to take those same Lambda services and run them down at, like, say, on your Raspberry Pi out in the field someplace, or connected over an intermittent connection. It can actually manage that process of talking back and forth with the various Greengrass cores that are out there and running your Lambdas, at that edge part of the location. I mean, some kinds of operations may be due to data restraints or bandwidth constraints or security issues. You may want to do some of that processing at the remote edge location before you bring that data back up into, say, the AWS cloud, like putting it into Dynamo or some DB inside the actual cloud itself. So you can see in the diagram here, the Greengrass core is also considered a device. So you'll have some kind of a core device running the core software on it. It can then deploy the Lambda functions just like you'd deploy into the AWS cloud itself, except they run on the core device. You just include the Greengrass core SDK inside your Lambda, and that enables all the additional functionality that allows you to then deploy them en masse to your groups of devices. And all the communication goes back and forth over MQTT, which makes it really nice and easy to manage. And actually, Amazon takes a lot of that part off your plate for you. Another benefit here is going to be offline operation. Maybe some of these operations need to be long-running processes, and maybe there is just intermittent connectivity. The devices themselves actually have shadow data that they maintain and can push that shadow data up into the IoT cloud whenever the device comes back online. So this gives you the ability to have a disconnected operation, still run the processing. Maybe you are bashing up and queuing sets of data to be uploaded into the AWS IoT cloud. That the Greengrass cores can do all that operation while you're disconnected, keeping their own set of data local until they get the ability to push that data up to the major to the IoT cloud itself. The Greengrass cores themselves can actually have other devices, and in their world they're called things. So maybe you've got a single core device at a location, but maybe you've got hundreds of small sensors that can't run the full core software itself. The Greengrass SDKs allow for local messaging between cores or between what are called things, which are just the devices themselves. So you may have an array of temperature sensors or whatever the sensors arrays may be running out there remotely, and every one of those devices does not need to talk back up into the Amazon cloud. Actually, they may want to be aggregating their data streams into a single spot before you upload them, because it could get very expensive if you were continually uploading data into the cloud versus batching it into single puts into like DynamoDB, for example. So to do that, you just make sure you're leveraging the Greengrass SDK. So local messaging actually can happen even if there's no connection to AWS. So if you're using that offline operation or you have intermittent connectivity, all the local messaging between the things and the devices inside the local network actually can happen. So this allows you to process rules, deliver messages to other devices, or even up into the cloud without having to have that fully connected connection to the AWS cloud. Now, another benefit that you don't get with standard AWS Lambdas is the function, the cloud functions or the edge functions you write actually have access to local resources. So for example, serial ports and GPIO and sensors and Bluetooth, cameras, for example, that are on those devices. The devices will have, extended, because of the Greengrass Core SDK, have extended ability to talk to those kinds of devices. So for example, you can have one-wire temperature sensors hooked up to GPIO and very easily monitor an array of temperatures across whatever your application may be, and that data can be accessed directly from the Lambda scripts as you write them. It's very easy to access those local hardware resources, and I'll show a demo of that as we get into more of the hello world and demo type area. In addition to the local resources, Greengrass supports some built-in connectors. So the Greengrass connectors give you access to additional hardware for doing inference. So for example, if you wanted to do machine learning inference at the edge, instead of transferring all the image data up to the AWS cloud for doing the inference inside the cloud, you can actually train your models inside of AWS, download those models and perform the inference actually at the edge without having to transfer the data. Again, in certain kinds of operations, maybe you're in a factory in a real-time operation, you don't have the time to wait for the video or images to go up to the cloud before the inference to be done and have decisions being made. So Greengrass connectors can actually help facilitate that. It also gives you access to third-party APIs. So for example, you can push messages into Twilio or Salesforce. There's a whole bunch of opportunities there for running different connectors into pre-existing tooling that's out there, and then also accessing into, say, on-premise software. So maybe you've got on-prem services that are running, and you don't have the ability to take that and put it into an AWS cloud. You can actually have your Greengrass cores talk to those on-prem softwares. The other bit that I mentioned here is the Greengrass connectors. Is it actually has pretty good support for existing AWS services as well. So for example, pushing metrics into CloudWatch, having Docker Compose on the cores run and launch applications. So some of the common AWS cloud type operations can actually happen on these little devices or even big devices running in your edge locations. I already kind of mentioned this, like running machine learning models, doing local inference, that helps reduce costs on transfer to the cloud. So again, a big benefit of being able to do that either faster or cheaper without having to do all of the transfer. The Greengrass cores are supported by a ton of hardware, but if you actually want to get started and start playing around with it, it's very easy actually to just go grab a Raspberry Pi, Pi 3 or Pi 4, install just the plain Jane Raspbian onto the Pi, and then from there, I'll show you a quick way to bootstrap the Pi and add it into the Greengrass Core or Amazon Cloud, and then you'll be able to start managing it and deploying Lambdas down to it. Some other interesting hardware in here, like for example, like the Tinkerbot. There's some Tinkerboard are some really good choices if you wanted to do maybe more souped up inference. I don't know if the Pi has well, it doesn't have the GPU. I don't know if the latest one does or not, but it may not have the GPU or power to be able to do that in an effective manner. But there are some little boards, like for example the NVIDIA boards that have GPUs on them, where it may actually make sense for your application. There are also, for example, a lot of gateways devices, like IoT gateways and existing edge devices that have the ability to run Greengrass Core or to be a thing deployed as part of a deployment using Greengrass Core. So definitely check those things out. Let's see. So the kind of quick start, we'll do a quick little demo here, and I'll see if I can actually show some of this going on. So if you have your Raspberry Pi, you've already flashed it, you can actually, from your own local device, your own laptop, do an assume role. So you will go into your account, you will create some kind of a temporary admin role inside of IAM, and then you can do that assume role. It'll give you in the output a temporary key ID, access key, and session token. So you'll copy those, and on your Pi, you'll just export those as environment variables, and then running this script, which a little bit cut off here at the bottom. I don't know if you can kind of see it, but basically the slides are all on my GitHub. So if you actually go to github.com/CalvinHP, you can download these slides, and it has all this sample code in here. You literally export those environment variables, run that script. It will do an interactive install onto the Greengrass core, or onto your Raspberry Pi to turn it into a Greengrass core. For production deployments, you probably don't want to do it in this manner, but to get a feel for how the whole thing works and to really make the process easy to get set up, it's a lot easier to use this interactive bootstrap process. Once you've got going with Greengrass and maybe you're deploying it to thousands of devices or even hundreds of devices, you can actually, there's a lot more better provisioning techniques for doing this. And then you'll generate keys, certificates. Each device will have their own set of certificates that's used to encrypt all the sessions, and then also to identify the core into Greengrass itself. So let me show a quick little demo here. Well, actually, I'm going to show some of the concepts first. So inside of Greengrass, there's a whole wide world of new terminology, and so it seems like every product feels like they have to make up their own words for all these things. So their words for things literally are thing, core, and group, which are very generic, kind of hard to talk about. But if you think about it, devices, like a Raspberry Pi or a sensor or some other embedded gateway or device, those are all considered things. Things can be similar, like to smaller devices. Now, cores themselves would typically run will run the Greengrass core software on them, so they need to be a little more powerful than, say, just a small sensor or type of device like that. But a core can now talk to all of the things in its local network, and then you can manage many cores, like hundreds or fleets of cores, as groups inside of Greengrass. So you'll see that there are Greengrass groups where you can now set up all your various groups of cores themselves. So let's talk about a quick hello world. When you install the interactive bootstrap, at the very end of the install process, it'll actually ask you if you'd like to install a hello world, and that hello world is straight out of the SDK. So if you actually go to Amazon's GitHub and download the Greengrass SDK, it's all Python, and so it's meant to be used with currently Python 3.7. So if you are creating Lambdas to deploy onto Greengrass, currently I believe you need to use Python 3.7. I assume 3.8 support is coming soon, because when I ran the interactive bootstrap, it actually told me it checked for Python 3.7, 3.8. The Raspbian version I had only had 3.7 installed and not 3.8. So make sure you choose Python 3.7, or else your Lambdas won't show up as deployable for your Greengrass cores. So if we walk through this bit of code here, actually, I'm going to open it up in my editor so you guys can see it a little easier. You all. Okay. Ooh, that's going to be really small. Let me make that bigger. Why is my computer not working? There we go. Okay, so if we go to and also the code from the GitHub includes the demo that I'll be showing here. So if we go into the core, okay, perfect. So I've built up a small little demo in here with a makefile that actually will help you package up your Lambdas and make it easy for you to kind of drive this process. Let me actually open up the Lambda now. Grab right mouse. Okay. If we head over to Lambda, because it went ahead and installed a Lambda for us. Go into Lambda. I'll make this font bigger for you. Okay, the Greengrass Hello World got installed. It looks just like a standard Lambda inside of our AWS console. You can actually edit it through the web or upload a zip file or manage it in just any the regular ways you would manage your existing Lambda code. But once you have uploaded it, you'll see that it's got the output here from the Greengrass, uploading its Lambda in here. There we go. Make that over here. So here's the Hello World. Kind of the basics of it is you make sure your Lambda imports the Greengrass SDK. So if we look right here, we've imported the Greengrass SDK. At that point, we create a connection to the Greengrass SDK called IoT data. There's a couple different types of connections you can make, but in this case, we're going to use the IoT data so that we can send and receive messages across various MQTT topics. And when you post to a topic, or publish to a topic, the IoT data is the type of client you're going to want to be able to do that. And then down here at the bottom, basically this hello world just is continually, it's a long running Lambda. So you can set it up so that it runs for a long, like different than kind of the normal Lambdas where they execute on some kind of event like a schedule or events happening in CloudTrail or CloudWatch. These Lambda events actually allow you to spin up a long running process on the Raspberry Pi itself. And so this one will basically publish to the topic hello world, every 5 seconds, the sent from my Greengrass core. So if we go look, we can actually see where it has done that. Go. So if I go back over to IoT Core, so all this is found underneath the IoT Core. So once you've got your Lambda set up, you'll head into the IoT Core area. And if you want to test it, you can click test and then subscribe to that topic, hello/world. And now it's basically listening for any events coming from our Raspberry Pi. So that's actually coming straight off this Raspberry Pi that is running over here on my desk. It's just plugged in and connected onto the Wi-Fi with power supply. All we got going. So you can see those are coming straight off the Raspberry Pi itself. If we look back at the Lambda, you can see here that you set what topic. So that's why I typed in hello/world on the subscribe, and then it basically has a nice payload. It's very easy to understand. So it's very kind of straightforward Python code here. And then different than what you would normally have is like this Greengrass hello world run, is that it can run a long running process. So normally you would have a function handler to run an event-based function. But in our case, we're just going to fire up a continuous loop that sleeps, or it runs every 5 seconds. So a little bit different than what you normally have in your Lambdas. So that was an example of a long running Lambda. Come back over here. Now to set those Lambdas up, actually I'll kind of start at the top here. We can now monitor our fleet of IoT devices. So if we look in the last hour, we can see there's been some messaging sent. Actually, I'll go for a day, so it's a little more interesting. Here we go. So that was me testing last night, sending messages to the Raspberry Pi. So sending events that way and getting responses back. But you can see that you get kind of this little dashboard showing you the status of your various devices. So here is my Raspberry Pi sending the hello world messages all night. And this was me sending messages to the Raspberry Pi looking for certain events specifically. So I'll show that kind of a Lambda off as well. So I've got a couple other Lambdas that are in here. Go back up here to functions. Another one of the hello world demos is this counter function. Each invocation, or each time the Lambda is spawned, it can have its own data storage, obviously like local variables. And so this is an example of using those local variables. So if we come down here, you can see that the function itself has a counter instantiated when the Lambda is created. And then the function handler is using that global. So each process on the actual Raspberry Pi running will get its own counter. Actually, I can show you on the Raspberry Pi what this looks like. Here we go. So you can actually see the processes running up here. This is the Greengrass core currently running. And you can see there's 3 Lambdas. There's a Python Lambda runtime right here that is currently running these Lambdas live on that Raspberry Pi as we speak. So if we go back to our test and do the hello world counter, the hello world counter is different because it's not continually sending messages back like the hello world one was. It's actually waiting for a trigger. So we subscribe to hello world counter. If I spell it correctly. And then I've set up a separate topic called hello world counter trigger. And that trigger is what actually sends the MQTT message to the Pi itself. And then the Pi responds in response to that. So you can see here I got invocation count 1. If we hit it again, we should get an invocation count 2. And then if we wait the 25 seconds for the timeout, then we would see the invocation count drop back down to 1, because after 25 seconds, it's going to hopefully try and recycle that process ID on there. So there we go. There's a second invocation that came after the 25 seconds, and it had elapsed on the Raspberry Pi itself. These are all set up inside the Greengrass on your inside the groups. So for each group of cores, you will manage the Lambdas that are deployed to them. So if we go to the Cloud Conf group for the cores, we'll be able to see the Lambdas that are here. So here's the 3 that we've got. I've shown you the 2 demos for the hello worlds, and we'll talk about this 3rd one here in a second. The trigger bit is set up inside the subscriptions. So you'll set up the subscriptions, basically wiring together what MQTT topics will result in either a message being sent to the Pi, or I'm subscribing to something and I want to send it into the IoT cloud for capturing that data and then doing something with that data. So you can see here, these are the various topics. So there's the hello world counter that comes from the IoT cloud. So that's why we're sending a message from the cloud down to the Pi. And then it invokes the Lambda. I'll edit that so you can kind of see it. Oh, I can't edit it. But if we added a new subscription, you choose your source. So for example, if we want to send messages from the cloud to the Pi, we would then choose our Lambda. And then when we click next, it'll ask us for what topic filter. So which specific messages should go to the Pi, and then the Pi will respond onto whatever queue the code is setting up to publish to. Cancel it here. And let me show the last demo. The last demo actually shows interacting with hardware. So we're going to ask the Pi for like CPU info, so something that's in the file system that you normally not have access to from a standard Lambda. Show you that code. Actually, I'll show it to you from them. Here we go. So here's some example code that's going to talk to /proc. So with the Greengrass SDK, you can actually grant access to /sys and /proc for accessing information about the hardware. Or if you're using the Greengrass connectors, you can then talk to GPIO pens and cameras and other local devices themselves. So in our case, we are going to literally open up proc/CPU info, read that, and then we're going to first of all log it, because that helps with debug process. Since these things are running on remote devices, they're running as Lambdas, it really helps to be able to put in logging information to help debug what's going on. The logs themselves are going to be on the Raspberry Pi, because that's where the Lambda runtime is happening, and I can show you where that actually gets deposited, so it's easier for you to find. But yeah, I was having trouble figuring out why I wasn't seeing my messages come back. But once I put in some logging here, and then down here at the end, like for example, if there's an exception, I wanted to log it out so I can capture it. I mean, you may be better to push that into like CloudWatch logs, but for now, just for quick debugging, just using the standard Python logging worked really well. And then we just do the same thing, publish onto a specific topic. So we're going to publish to Hello World CPU. So we'll come back in here to our test. So if we subscribe to Hello World CPU, and then we push a message to Hello World CPU /trigger, we should get a message back from the Pi. There we go. It was very quick with the message from /proc/CPU. So now we can get the hardware details. For example, if you wanted to measure the temperature of the CPU cores for monitoring of the actual hardware devices, you could do that very easily here with the Greengrass core pieces. I think so. Let's see if there's anything else I really wanted to show in here. I mean, underneath the groups. Oh yeah, so like for example, deploying. Each time you make a change to your Lambda code that is running over and like, well, you mess with and kind of interact with via the standard Lambda tools, you will have to come back over here and still deploy. One of the things they recommend in the documentation is to basically tag your Lambdas with an alias. So if we actually look over here, I'll come back to the CPU demo. You can see that I published it 19 hours ago. If I wanted to publish a new version, I've created an alias for it. And so I will point my Lambdas in Greengrass to the alias so that I don't have to continually update what version is getting put into Greengrass. You can just follow along with, like, say, latest or current release or stable. So basically, it's like following a specific release branch of your Greengrass. So if I publish a new version, you can see here, this is standard Lambda stuff. I'm not going to go over like how Lambda works there. But if you come into here, once you have made a change, you still need to come and click deploy, or you would want to deploy, do that operation through your own orchestration system. But you can see it's going to deploy right now straight to my Raspberry Pi, which is just on the Wi-Fi. And if I had more cores in this group, it would send out that update or the Lambda to all the cores that were currently connected in the group. And any cores that weren't connected at that point in time, that update and deploy would queue up and be deployed once the device came online. So there we go, successfully completed the deploy. So now the Lambda, the new minted version of that Lambda is running on the Raspberry Pi. Nice and easy. Okay, let me move this stuff out of the way. I think that's all for that right now. Okay, so that's kind of the hello world intro to using Lambdas with Greengrass cores and the groups. The last couple bits here is talking about kind of security and some other features of Lambda that are nice for you to use. The Greengrass works with the AWS Secrets Manager. So you'll see it's called Greengrass Secret Resources now, but it integrates with Secrets Manager. So if you have, for example, API keys for your Twilio or Splunk or third-party APIs, you can now store those in Security Manager on AWS, and your Greengrass devices can access them, given whatever role they have or permissions they would have. So that works with the connectors. It also works with Lambdas. Make sure you rotate your keys and distribute the access, and distribute access to the other edge resources. So keeping, kind of good security hygiene. Other nice things with Greengrass that they seem to be growing a lot of new features around is Greengrass security around policies. So just like with IAM roles and policies, you can put policies onto your Greengrass devices. The other interesting bit here is Device Defender. So Device Defender can actually conduct audits based on either on demand of a fleet of devices or as a scheduled or on-demand process. It basically monitors for device activity and looking for, you basically create security policies to define what normal device behavior would be. And you can actually create automatic mitigation actions that can happen. So if a device goes rogue or maybe it's gotten compromised, you can actually have specific kinds of actions that can either shut it off the network or take some kind of action for you. There are ACT rules, which is basically like if this then that for IoT on AWS. So evaluating messages coming back from your various core devices and then routing those messages to either AWS or third-party IoT services. Really makes kind of point and click, make it very easy to set up. If this message comes back contains certain kinds of data, shove it over into this DynamoDB versus that DB, or versus going into the Salesforce IoT connector. So people may be wondering, what does this all cost for this amazing miracle of AWS managedness? So the Greengrass pricing, you basically, there's like a free tier, like a lot of the other AWS services, up to 3 devices per year. For up to 10,000 devices, it is 16 cents per month per device, and you only pay when that device is active in that month. So if some of your devices aren't active in a month, you don't have to pay for them on an ongoing basis. There is a reserved instance type model for it to get a discount on an annual commitment. They are billed, the 16 cents part is billed in whole months. So anytime one of the devices comes online during that month, you would get billed the 16 cents for that specific device being online. Now, the other bits you have to kind of keep in mind is you're still going to be paying for things like transfer and storage and any other AWS resources that you would use through the course of all the work that's going on. So if you're storing data in DynamoDB, you may want to be very cognizant of how often you do puts into DynamoDB, because that really may change how your pricing works. So you may want to batch up, if you're doing temperature sensor reads every 10 seconds, you probably don't need to send that data into Dynamo every 10 seconds, unless you do. But if you don't, there are ways you can manage batching that up and then sending them, maybe once a minute or once every 10 minutes or whatever the business case may be for having that data in a relatively sane time frame up on your system. Other than that, there are resources here. So that is the address to the GitHub. There is the Getting Started guide, which is where you can kind of do the hello world exercise. The FAQs are very helpful as well. So if you have any questions, I'm happy to answer them. We have the closing remarks in about 9 minutes, but feel free to ping me on Slack, or if you can find me or ping me and say, I'd like to quick meet. We can basically jump in one of the breakout rooms and I can answer any questions you would have. Here's my email address and my Twitter handle. Again, I'm very open to questions, so please feel free to come find me, stalk me on the internet, and I'll do my best to answer them in any way I can. I want to thank you all for enjoying this talk, hopefully, and we will see you next day. Well, actually, so we've got the, excuse me, we will have, I'm looking at the wrong room. So I don't know, Carol, are there some questions? I think there's some things going on in the IoT room that I was not paying attention
Yep,
for.
nothing that I saw that came through for you.
So David did ask, when batching up data points, what business criteria can you think of that would lead you toward more or less granular? I mean, it's all a balance. You're obviously looking at like a cost versus performance type metric. If the data is only going to be looked at once a day, you know, there's no reason to write every 10 seconds. If you need to take action on the data at a very high interval, say like every couple milliseconds you need to be doing something, then really that compute should be happening at edge, and just the result of that type of work should be sent up into the cloud versus waiting for it to go to the cloud, take some action, and send it back down to the edge devices. So I think it really depends on the business case for the type of actions or type of lambdas or whatever the thing is measuring. If the data has to be read right away because there's some kind of decision that has to be made based on the data. I don't know if there's any other questions. That was I snagged that out of the IoT room. I think that was the only one in there. Because David was correct, this was supposed to be in the IoT track, but I asked them to switch it so that it was easier for me to moderate this track.